Good morning, grade 7s. Welcome to your daily mathematics lesson brought to you by WorksheetCloud.com. Hope you guys are well after the long weekend. I hope you are making the most out of the opportunity to get out your house early in the morning and get some exercise done, especially before you get into your academics. And yeah, I hope you guys are really well. A reminder of the email address on your screen, grade7@worksheetcloud.com. Use it, send me some questions, queries, anything we might have covered, anything we haven't covered, I'm more than happy to answer, and I look forward to those emails continuing to come through. Okay, so today we're going to look at symmetry, reflective symmetry or line symmetry. So we're staying with the geometry theme, and then you've got your normal warm-ups, brain benders, challenges on either side of that. Okay, so let's get into your warm-up for today. Use your math skills to work out the value of the symbols on your screen, and remember the question mark at the end. Press pause, and then let's see how you guys get on. Well done for working through that. I'm going to give you the model answer. Let me just get onto the Google Jamboard. Okay, there it is there. So if you tried out some numbers, it's a little bit tricky. I think I would have probably started here and looked for numbers that would have given me the answer of 9. And I played around with a few things and then realized that it was indeed simply just 9. Plus 9 is 18, minus 9 is 9. Okay, so if it took you a while to work that out, don't stress. And then once we've got that, we can kind of fill in other answers. We know that 0 is going to be equal to 0 multiplied by 9. Okay, so I'm saying the balloons are 0. Then if I go to the top line, something plus 0 plus 9 must equal 50. So the magic hat must be 41. Okay, and then I can fill in what I know. And that will equal 41 minus 0. There we go. Okay, and then right at the bottom, the magic hat's 41, the balloon is 0, and the feathers are 9. And we should know that anything multiplied by 0 is 0. So it doesn't matter what order you do that question in, the answer will always be 0. Okay? All right, well done if you worked through that one. So your mental arithmetic questions for today are those on the screen, a combination of some percentages, fractions, some angle work, and some decimal work, and long division. Take your time, work through them, there's no rush. Just press pause and then play when you're ready, and we'll work through them on the Google Jamboard. Santa's mass increased from 80 to 82. What was the increase as a fraction in its simplest terms? So it increased 2 kilograms over the original amount of 80 kilograms, and that equals 1 over 40. Okay, and then I need to convert 1 over 40 to a percentage, and to turn something into a percentage, sorry, not equals, we multiply by 100 over 1, okay, and we can cancel that out. 20 goes into 40 twice and into 100 5 times, so we're left with 5 over 2, and that is 2,5%. Okay, so the important things to remember there is that the increase is always over the original amount, so it's 2 over 80, and then to multiply by 100 over 1 to get to a percentage. Then you needed to work out the reflex angle, and I'll just go back to where the mental questions are there. So you can see that you got 360 degrees in a full revolution. You need to take off 47 degrees, and that will leave you with 313 degrees. Okay, and in question number 3, you needed to find the angles in the triangle. So the first thing I would have done is ACB. I know that 130 needs to add to its adjacent angle to give me 180 degrees because it's a straight line. So ACB must equal 50 degrees. And then if I know the two base angles, 50 and 55, then BAC must be 180 minus 50 and 55, and that will give me 75 degrees, and that looks like that. Okay, so just a reminder that when you work out a reflex angle, you subtract the interior angle from 360. And then to work out the angles of a triangle, you know that they add up to 180. You need to know that your interior, your straight line angles add up to 180. And also remember we spoke about this exterior angle adding up to the opposite two interior angles. So this 55 and this 75 need to add up to 130. And 55 and 75 indeed do add up to 130. So well done if you remembered those principles from previous lessons. Okay, question 4. If x divided by 6 is equal to 8,53, then what is x equal to? So there we just need to work backwards and say 8,53 multiplied by 6. Okay, so you can either do a column method, you can split it up, 8 times 6, 0,5 times 6, 0,03 times 6, okay. Let's do the column method. Okay, and the important thing with the column method is to obviously remember to carry and to line the decimal up so it's all in the same place. Okay, and 6 times 8 is 48 plus the 3 is 51. So your answer is 51,18. Please guys, don't say 51,18. Okay, it's 51,18. 18 is obviously on the left hand side of the decimal sign. So anything after the decimal, we talk about it as a singular number. So 18. Okay, that's just a little bit of technicality for you. And then for question number 5, a long division question. So I need 924 divided by 44. And the first thing I'm going to do is multiply it by 10. And that's going to give me 440. So I know that if I multiply by 20, that gives me 880. Okay, I then can see from 880 to 924 is an additional 44. Okay, so my answer there is going to be the 10, not the 10, the 20, and that additional 1. So my answer is going to be 924 divided by 44 equals 21. Okay, so there I've worked out division using multiplication, and I still believe that multiplying by 10 or multiples of 10 is a hell of a lot easier than doing a long division algorithm. Okay guys, so well done if you worked those out. Let's get into today's main theme, which is reflection. Okay guys, so I've just got some shapes on the screen that can show you a bit of reflection in real life. Those are some man-made images, and you can see on there that if you had to cut some of those shapes in half, they would indeed fit on top of each other. This is the same introduction that I showed the grade 6s, so this should be more of a recap for you than anything new. Okay, and there you can see some symmetry in nature, and it's quite amazing how much mathematics you can actually see in nature. Okay, so everything there that you can see is reflective symmetry, and you can also see in the butterfly on the bottom left that could be seen as line symmetry and reflection symmetry, as well as the Alsatian on the top left. Okay, so you can have symmetry in music. There's some man-made symmetry. Okay, so we do see a lot of symmetry in construction. So there you can see how symmetry is used in real life. Okay, so objects that have one line of symmetry, so you can have a look that each of these objects, if they're folded along their vertical lines of symmetry, they will fold on top of each other. Okay, so they have one vertical line. We also have horizontal lines of symmetry, and we have diagonal lines of symmetry. Okay. Some objects have two lines of symmetry, which is very possible. And there you can see that the first one has horizontal and vertical, two diagonals, horizontal and vertical. Okay, so there's some objects with two lines of symmetry. And now a common error that a lot of students make is they think that rectangles have more than two lines of symmetry because it's similar to a square, but that's not the case. Okay, and we'll get into that just now. So if you had a look at half a rectangle, so the reason we say half a rectangle is because, well, you would expect if it was 4 lines of symmetry that if it was diagonal, the other half of the rectangle would fit perfectly on top of it. However, if we put in some tracing paper and we take our pencil and we measure over, or we draw over what we want to reflect, and we reflect it into that mirror line, so you can either draw it and fold it over the mirror line, or you can actually have a mirror and have a look. You'll see that the drum roll shows you that it does not fit perfectly on top of the original half a rectangle. Okay, so that's the reason behind a rectangle not having 4 lines of symmetry and only having 2, a vertical and horizontal. Regular polygons Okay, so my typewriter there says regular polygons have lines of symmetry equal to the number of sides or angles that they possess. So remember, regular polygons, all sides and all angles are equal. So an equilateral triangle, you would expect it to have 3 lines of symmetry. Okay, in a square, 4 equal sides, 4 equal angles. So you know the square is going to have 4 lines of symmetry. In the pentagon, 5 equal sides and angles, so yes, therefore it has 5 lines of symmetry. And the same with the hexagon, 6 sides, 6 lines of symmetry, and the octagon, 8 sides and 8 lines of symmetry. So again, guys, this should be a recap from previous year's work. Here you have a reflection in some square paper. They've given you the mirror line down the middle, and the important thing to notice here is obviously that's the object. We take our tracing paper, we trace over the object with our pencil. Okay, we have the mirror line, we fold the object over the mirror line, and the tracing paper will land up on the other half of the page, and we can draw over it and make the vertices, remove the tracing paper, okay, and there is our image. Now the important thing here to notice is that the image is exactly the same distance away from the mirror line as the object. Okay, it's the same thing as if you looked in the mirror, the further back you stand, the deeper you go into the mirror, and it's the same thing when we do reflections in maths. Here's another example. So there's your mirror line. They've given us a kite as an object. We trace over the kite. We draw over the mirror line. We fold the object over the mirror line, and the tracing paper ends up on the other side. We mark off the vertices. Remember, vertices mean corners. And we join those up, and our image is given to us. Okay, notice that the image touches the mirror line, as does the object. Right, another example is a diagonal line of symmetry. Okay, so sometimes these ones are tricky to work out if you don't have a piece of tracing paper or a mirror handy. But if you do have your tracing paper, you can draw over the object, draw over the mirror line, okay? Fold the object over that mirror line, and you would see that the image comes out slightly differently to a horizontal or vertical mirror line, okay? So just make sure that you are using tracing paper and that you are actually folding over the mirror line as accurately as possible. Okay, I've just put this little diagram in just to show you that the image needs to be the exact same distance away from the mirror line as the object. Okay, so that's just to highlight that point. It's a very important point, so please remember that moving forward. Okay, so this is a little bit different from grade 6. You might be asked to reflect in the X and the Y axis. So you should hopefully know that the X axis is the horizontal axis and the Y axis is the vertical axis, which gives us 4 quadrants. So if I asked you to reflect in the X axis, that would be where your image would lie. Okay, so notice it's the same distance away from the X axis as the object in blue. All right, if I asked you to reflect it in the y-axis, which is the vertical axis, it's 1 square away from the y-axis, so the image also needs to be 1 square away. Sometimes the x-axis or the y-axis moves, so there they've asked us to reflect in the line y equals 1, okay, and that dotted line, everywhere on that dotted line, y will equal 1. Okay, so same thing applies. The image has got to be the same distance away from the mirror line. So the new mirror line is now the red dotted line, and there you can see your object underneath it. They could tell us to move, they could move the axis, the vertical mirror line as well. And there they say that x equals -1. Don't worry too much about x equaling -1. The important thing to note is that the object is 2 squares away from the new mirror line in red, so therefore your image also needs to be 2 squares away from your mirror line. Okay, and then we have a diagonal axis, okay, or a diagonal line that you need to reflect in. And as we did earlier with our tracing paper, you do the exact same thing. Trace over the blue object, fold over the mirror line, which is the red dotted line, and you'll see that that's where the image of the triangle ends up. Okay, so my biggest piece of advice to you is to try get a piece of tracing paper, and if you can't get tracing paper, then use some normal paper. Just make sure that your object is drawn with a darker fine liner or a darker pencil, so that when you do draw over it, you can actually see the object that you're tracing, and then just fold it over the red dotted line or whatever the mirror line is. And that's where it would be. Notice that the image is the same distance away from the red dotted line as the blue object. And then another example for you for that diagonal line is B7, but I'm sure you guys have grasped the concept by now already. Okay, so that's reflective or line symmetry. Go have a look at your online activities that I've left for you today. I've left you with several examples of reflective symmetry or line symmetry. I think there are about three worksheets there where you can actually draw them into your book, use some tracing paper, and have a look at how you go. So yeah, I encourage you to make the most of the online activities that we give you. Your finisher for today is 24, and you guys are progressing nicely towards some more difficult 24 problems. So by now you should know that you must use all 4 numbers on each card. Use any of the operation signs, use all of them, a combination of them, and get the answer of 24. Okay, so for example, on the first one I would say 4 times 4 is 16. 16 plus 3 is 19, and 19 plus 5 is 24. Perhaps there's another way that you can go about working it out. So remember, see how many different ways you can get to 24, and that's the second part of the challenge. Grade 7s, thanks very much for tuning in today. I hope you remembered those concepts from grade 5 and 6, and I hope that you grasped the concept of reflecting in the X and the Y axis. And as I said, go and practice the online activity. Have a great day, and I look forward to catching up with you guys during the next lesson. All the best and stay safe.